again. Okay, thank you so much. Let's get from search and see. Search and please define for us volume. Search and we are waiting from you. Please unmute and then you give us the definition of volume. Okay, members, let's go on. It seems the network is disturbing them, but let's go on. So we are going to look at those terms. So let's go on with the terms we are going to look at. We say volume is the space occupied by an object. So when we say the space that an object can occupy, that qualifies as volume. Then we shall also look at another term which we called molecules. So when we say molecules, molecules are smallest particles of matter. So when we look at matter, matter is made of small particles. And those particles are the ones we call molecules. Are we together? Yes. Then we shall also look at weight. Weight. First of all, we shall know that weight is a force. Weight is a force. And being that it is a force, it will be measured in newtons. We shall say that weight is measured in newtons. Being it is a force, that's why we say it is measured in newtons. As we define weight, we shall say is a force exerted on an object due to gravity. Even the definition talks about it is a force. So since it is a force, we shall say it is measured in newtons. So when can I get someone to define for us Asinguza? Please, can you unmute and define for us weight? Asinguza, please.
Weight is the gravitational force exerted on an object by the earth.
Very good. That is another alternative. Beautiful. Good. So we can also define it as is the force exerted on an object due to gravitation or due to gravity. And we are going to look at the properties of matter. I think that is P3 work. Some of you learned about properties of air, properties of matter in P3. So let's go through it very fast and we give the properties. The first one we have, can I ask Ayebaziwe to define, to give us the first, to read for us the first property. Ayebaziwe, please. Read.
Matter has weight.
Yes, matter has weight. That is the first one. We have the second one, which is matter occupies space. And then the third one is matter exerts pressure. Atwaire, can you read for us all the three properties? Read all the three properties. Please unmute.
Matter has weight.
Yes.
Matter occupies space.
Then
matter exerts pressure.
Wow, wonderful. So this one will take us to the experiment to see how all the three properties of matter can be experimented. So I want to start with to find out whether matter has weight. We want to see whether matter has weight. Now, in simple, as you're at home, you can carry out this experiment. One, you need two balloons, preferably have two colors, red and maybe yellow, any other color, but have two colors. And then you can also have a local made weighing balance. When I say a local made weighing balance, you can get a pole and then you tie there something, or you put a nail so that the two sides are balancing, as you're going to see it. Then you blow air in each of the balloon and make sure those balloons are the same size. Don't use a big size balloon and then the other side use a small one. Let them be of the same size. After blowing in air, of course, you have to tie the balloon with the string to keep that air inside as you continue. Then from there, we shall need to tie the balloons on the weighing balance which you have made. Are you following me, girls? I hope yes. Then after tying, I think that one will be done after the lesson. After tying on both sides, you tie one balloon on the left side, you tie another on the right side, and then make them balance. Then after balancing, make sure at least you prick one so that the air gets out using a pin. You can use a pin. When you prick one, of course, air will get out. And then after that, you observe what will happen to the balloons, as you are going to see here. So when you look at our diagram here, the diagram A, the balloons were balancing, as I said. Balloons were balancing. Then when you look at B, someone was trying to prick the balloon, which was yellow. And then, of course, air has to get out. And when air gets out, what will happen? It will be deflated. Then when you look at C, you will see that the balloon which had air will move down. Then the other one which doesn't have air will move up, which means that the one which has air is heavy. That's why it moved down. So that one gives us a conclusion. Before the conclusion, these are our observations. That the deflated balloon will move upward, which that is, when we say deflated, we mean the one without air, will move upward. Then the inflated one will move downward. Someone, I request Nakaiwa Petron, Nella, please, can you unmute and give us the reason why the inflated balloon moves downward? Please unmute. Nakaiwa.
I beg your pardon.
The question is, why do you think the inflated balloon moves downward when we are balancing, or when we are balancing it with the deflated one?
It is because the inflated balloon has more air than the deflated balloon.
Very good, which means it is heavier. So that one gives us a conclusion that matter or air has weight. So let's go to another experiment. We want to find out whether air or matter occupies space. I want to ask Nyapendi Francis. Nyapendi. What do you know about, if we are talking about what can we use, or do you know anything to show or to explain that matter occupies space, or anywhere you have ever seen that? Maybe this one, I think matter occupies space.
I think that an object can occupy space. Doesn't it also mean that it is matter?
Okay, thank you. Yes, it occupies space. You see, for example, when you go to fetch, those who have ever got water from maybe on rivers, when you put a jerry can and you are fetching water, or maybe even if you use any other, a basin at home, you get like a water bottle, you try to fill it, you insert it in water, you will see some air bubbles. You will see some air bubbles coming out of the bottle. And when you see, that means the air which had occupied the bottle is escaping, and then the water is occupying. So when you see that, automatically it will show that air or matter occupies space. So let's look at our experiment. These are the materials we shall need. I request Namasaz Chirabo. Namasaz, please unmute and give and read for us those materials. Use it. Namasaz Chirabo, please unmute.
Beg your pardon.
Please read for us those materials.
A glass,
Yes.
water, and a container.
So thank you so much. We shall use those three to carry out the experiment. But since you are far, you do that experiment at home after the lesson. Try. I will ask you next time when we come. At least you tell us your findings. So the steps are simple. We just need to get an empty container, and then we invert it, or we put it in water when it is open upside down into the container containing water, as it is seen below. When you look at that experiment, you really see that the glass was put inverted, that is upside down. And then when the person on B tried to bend it, we see the air bubbles. We see the air bubbles getting out of the glass. They are not getting out of the water, but they are getting out of the glass, which means that the air which was in glass was trying to escape, which means that air, as we called it matter, occupies space. So observations we shall find, our observation is that air bubbles will be seen coming out of the glass, and then water occupies the space for the air. So conclusively on that, we shall say that matter or air occupies space. We got the last experiment for finding out whether air exerts pressure. I request Jorin. Jorin, please, can you read for us the materials? Please unmute and then you tell us. Jory. Jorin is not responding. Can I ask Chionga? Please, Chionga, can you unmute Chong, unmute and tell and read for us.
Cardboard, glass, and water.
Very good girl. We have the cardboard, or you can call it hard paper, then the glass, and then water. Only the three. Make sure the cardboard is very smooth so that there is no air escaping when we are carrying out the experiment as we are going to look at it. So we have the steps. The first step we are going to look at, we fill the glass with water up to the top. We make sure the glass is full of water. Then number 2, I request the Valeria. Please, can you read for us the second step? Valeria, please unmute. I can't get you well. Okay, can I get from Chitemu Judith? Chitemu Judith? Chitemu Judith, please. Unmute.
Turn
And read
the glass upside down carefully without pouring water out.
Read the second one.
Get a piece of a cardboard and put it on top of a glass.
Very good. We get a piece of cardboard and put it on top of the glass. Then I will also request Gabjera. Please unmute and read for us the third point. Okay. Can I hear from Asim and Nicole? Asim and Nicole? Please read for us the number 3.
Remove the hands carefully.
I said number 3.
Turn the glass upside down carefully without pouring water out.
Very good. All right. Then can I also request Julie Doreen? Please unmute and then
Remove the hand carefully.
you remove the hand carefully. Thank you so much. Thank you so much, girls. So let's look at the setup. So the first step, you have to you get your glass. You get a glass, you fill in water, make sure the glass is full. Then on top of the glass, put the cardboard. When it is still up, not when it's still upright. Then from there, you turn the glass upside down so that the water doesn't pour. And let it be faster. Don't turn it slowly. You turn it faster, but you keep holding down. Then after, you remove the hand, which was the hand that is holding the cardboard. And then you will see the water is not pouring. Then that one will tell you that air, our matter, exerts pressure as you look at that experiment. But there is something that you have to understand, that there is a reason why the water does not pour. The reason why the water doesn't pour is that the pressure inside the glass is equal to the pressure outside the glass. It is on our conclusion. I request Birunji, please, can you read for us the conclusion? Birunji, unmute.
The water does not pour off the glass because the pressure exerted by the air outside the glass is equal to the pressure exerted by the water inside the glass.
Yes. So there is equal pressure. The pressure inside is equal to the pressure outside. And that makes it the water to remain inside. And you do not see any drop of water. So that will tell us that air or matter exerts pressure. Now, we want to look at when do we apply, when do we use the knowledge of air exerts pressure in our daily life? Before we go on, can I request Liana Subi? Liana, please unmute and tell us how can we apply that knowledge of air exerts pressure, or where is it applied?
Teacher, you can apply application of air exerts pressure when drinking soda using a straw, when a doctor uses a string to get medicine from a bottle and injects it into the body. Very good, girl. Thank you so much, Liana. So she has talked about two applications where we can apply the knowledge of air exerts pressure. When you drink a soda using a straw, there is science there. So we say that that is air exerts pressure. Then we also talked about when a doctor uses a syringe to get medicine from the bottle and injects it to the body. The doctor is also using the application of air exerts pressure. Then lastly, not the last, but another point number 3, we shall also find that when pumping air into a car or a bicycle using a pump, that is also an application of air exerts. I don't know whether all of you have ever seen before. They pump using the hand. They see people pumping, which means they are applying the knowledge. I request Catherine to read for us question number 1 on our activity. Catherine. Unmute, please. Read number 1.
Name the units for measuring weight.
Beautiful. And who can give us the answer? Donna. Donna, can you give us the answer, please? The units for measuring weight.
Newtons.
Beautiful. Newtons. I am just happy. Seems you people, you are getting exactly what we are discussing. Okay. Vanessa, can you read for us? Read for us number 2.
Why is a piece of paper called matter?
Wow. Why is it called matter? Can you give us the answer?
It has volume and mass.
Very good. It has volume and mass. Someone can also say it has weight. It occupies space and other. Thank you so much, Vanessa. Let's get to Mugisha Deborah. Mugisha Deborah, please read for us number 3 and give us the answer.
Which property of air helps in inflating a balloon?
Yes, give us the answer.
Yes.
Mugisha, give us the answer for that question.
As weight.
I can't get you well. Okay.
As weight.
Which property of air helps in inflating a balloon? Teresa, please. Can you give us the answer number 3?
Air has weight.
Teresa, please.
Air has weight.
Thank you for trying. We shall say when we are inflating, we say air exerts pressure. Okay. When we say inflating means putting air in a balloon. All right. Can I ask Nafuka? Nafuka, please. Can you read for us number 4?
Mention the property of air which helps a mechanic to fill a car tire with air.
Which answer do you give there?
Air exerts pressure.
Very good. Air exerts pressure. Number 5, and that is our last number on this activity. I request Jocelyn, please. Can you read for us number 5? Jocelyn, unmute. Okay. Let me get from Treasure.
I don't have it.
Number 5.
I don't have it. It's not number 5.
Yes, number 5.
For me, the question.
Read the question and then give the answer. You don't have the paper?
Yes, teacher.
Okay, state the difference. State anyone. State 2 difference between mass and weight.
State 2 differences between mass and weight.
Yes.
Mass is measured in kilograms while weight is measured in newtons.
Beautiful. Wow. So let's go to the lesson 2. Under lesson 2, we are going to start with states of matter. So we shall find that there are 3 states of matter. 3 states of matter. So the first one, we have solids, lipids, and then gases. So I want to start with the first one, and that is those are solids. Can I have some examples of the materials which you think they are under solids? Bagala, please. Any material you think is a solid. Bagala?
Excuse me, teacher. I've not had the question.
Yes, I was asking.
Yes, teacher.
You give an example of a material which you think is a solid. Please, Bagada. Okay. Bagara is not. Unmute please, Bagara. Tell us.
Tables.
Tables. Good. Kakai. Kakai hand.
Plastic.
Wow, good. Teresa. Unmute.
Wood.
Beautiful. So we shall not give all of them, but there are many. So we have wood, we have rubber, glasses, we have plastics, and others. All of them are solids. But now we want to look at the characteristics of those solids. The first one, can I have someone reading for us the first characteristic? Muumba. Can you read us the first or give us the first characteristic? Okay, let's get from Elizabeth. Elizabeth. Elizabeth, please. Unmute.
Molecules are closely packed. Particles are held together very tight because they have strong cohesion forces.
Elizabeth, unmute.
Molecules have unmuted. Molecules are closely packed.
Thank you so much.
Particles are held together very tight because they have strong cohesion forces. Molecules do not move from position but vibrate. Solids have shape, size, and volume. Teacher? Molecules are closely packed.
Yes, we are saying.
Particles are held.
Thank you so much.
Yes, teacher.
Thank you so much for that liberation.
Yes.
So when we look at the arrangement of those particles or the structures, you really see that they have strong cohesion forces. The particles are closely packed, two held together. What makes that is because they have strong cohesion forces. We shall come to cohesion forces. But when we're defining cohesion forces, we say that they are forces of attraction. Forces of attraction between molecules of the same kind or which are the same, of the same particles. So as long as they are the same, we say those are cohesion forces. Then we shall come to liquids. When we're looking at liquids, we shall say we have seen many substances which exist in liquid form. Can you give me, I request Namudu. Namudu, please. Can you give us any substance that you know which exists in liquid form? Namudu? You're not responding, please. So let's hear from Kutesa Divine. Kutesa Divine, please give us any substance that you think exists in liquid form.
Mute.
What?
Unmute me.
Kutesa,
Water.
please. Another
Water.
one.
Juice.
Wow. Another one.
Petrol.
Wow. Thank you so much. There are many. We can't finish all. Then we have water, soda, oil, and then juice. Those are some of the examples of the substances that exist as liquids. All right. So then we also said we look at the arrangement. Before we look at the arrangement, let's look at the characteristics of liquids. Characteristics. Owengabo, please, can you read for us the first characteristic of liquids?
Molecules are moderately spaced.
Wow, they are moderately spaced. Thank you so much. When we say they are moderately spaced, it means they are not very closely packed and they are not far apart. Just in the middle there, moderately. Then we shall also come to number 2, and we shall find that molecules are loosely held. They are not too much held together. There is a bit of being loose. So we say molecules are loosely held together. I request Ninsima Martha. Ninsima Martha, please read for us number 3 on the characteristics.
Liquids have a proper volume, in brackets capacity.
Yes, we are saying we can get the capacity of a liquid. We can measure using different measurements, whether liters or millimeters or milliliters, but we can get that measurement. We can get the capacity of a liquid. But maybe what I have not talked about is that the reason why liquids are able to flow is because they have weak cohesion forces. They are loose and the cohesion forces are weak. That's why they are able to flow. Are we together? They have weak cohesion forces and then they are able to flow. Then number 4, which is our last point on the characteristics, I request Atrinda Medrin read for us the last characteristic of liquids. Unmute, please.
Liquids have no definite shape.
Repeat
Take
it.
up the shape of the container in which they are powered.
Read it again.
Liquids have a proper volume or capacity. Liquids have no definite shape. They take up the shape of the container in which they are powered.
Thank you so much. Liquids they do not have any definite shape. In other words, they take the shape of the container where they have been poured. Where you put it, that's the shape. If you put in a round container, they will take the shape of a round container. If you put in a cylindrical container, it will take that shape. So they do not have a definite or a well-defined shape. So when we look at the arrangements, you will see that the particles are not closely packed like in solids. Are we together? So let's look at gases. Let's look at gases. So when we look at gases, we are looking at some of the substances which exist in gas. One, we have nitrogen, we have carbon dioxide, oxygen, and rare gas. Now, can I request Abasa? Abasa, please unmute and read for us the first characteristic of gases.
Molecules are apart.
Very good. Molecules are apart, which means they are spaced. They are spaced. So, being that they are spaced, they can easily move. We shall come to look at it when it comes to heating. When we heat it, what happens? And we compare it with other states of matter. Then number 2, I request Navuga Gabriela. Navuga, please unmute and read for us point number 2.
Gases have no definite shape.
They also don't have a definite shape. They can ask you the similarity between gas and liquids. Both don't have definite shape as when you compare the two. Then number 3, we shall say that gases have a particular volume. We can also get its volume. Then lastly, molecules in gases move freely. I want someone to give me the reason. Nabide, please give us the reason why molecules move freely in gases. Nabide, please. Nabide. Unmute. Nabide, give the reason why molecules in gases move freely.
Molecules are far apart.
Very good.
They are not packed.
Very good. They are able to move. When you look at the arrangement there, you will really see that there is those arrows, which means they can easily move from one point to another because they are free. When you compare it with others, then you find that these ones are free to move. So that is on the states of matter. We look at our activity. Can I request Bide Twapoli? Bide Twapoli, read the first question. Unmute Bide Twa. Bide Twapoli. Unmute and read.
Mention the state of matter which has closely packed molecules.
Which state of matter is that? Can I ask Namirim? Please give us the answer. Namirimwe Claudia. Unmute please and give us the answer for number 1.
Solid.
Which answers have you given?
Solid.
The question is, mention the state of matter which has closely packed molecules. Okay. She's not giving the answer. I don't know. Let's hear from Nangendo Maria. Nangendo, can you give us the answer for number 1? Unmute, please.
Solids.
Can read the question and give the answer.
Mention the state of matter which has closely packed molecules.
And the answer is?
Solids.
Very good. Thank you so much. We got number 2. Number 2, I request Namutebi, Innocence. Anisent. Namtebi Anisent.
Yes.
Can you please read number 2 and give the answer?
Why does the state of matter mentioned in question 1 above have closely packed molecules?
Which answer can you give there?
Yes.
I can't hear you.
They
Go
have
on.
strong cohesion forces.
Very good. So good. Because it has got the strongest cohesion forces. Others have forces. They have the force. But the other one has got the strongest. That is the solids. All together. So let's look at number 3. I request Adrian, Patricia. Can you read for us number 3 and then you give the answer?
Which force of attraction holds molecules of the same kind? B. Different kinds. Which force of attraction holds molecules of part A the same kind?
Which answer do you give there?
Cohesion force.
Very good. Cohesion forces.
Force.
Cohesion forces.
Force.
What about B?
Molecule. Which force of attraction holds molecules of a different kind?
Which answer do you give there?
Adhesion force.
Beautiful. Wow. We have cohesion forces and adhesion forces. Those are forces of attraction. Between same, those are adhesion forces. Different, those are adhesion. Same are cohesion and then different adhesion forces. Number 4, can I request Nairuba Trinity? Nairuba Trinity. Okay, let me get from Sally Angel. Not Sally Angel, not Sally Angel. Not Sally Angel, please. Number 4. Nasal Angel, read number 4 and give us the response. Nasal Angel, you are not giving us. I'm waiting. Okay, can I request Babidia Grace? Babidia Grace, please read for us number 4 and give us the answer.
Mention one state of matter in which molecules can flow.
Then give the response.
Liquids.
Very good.
Liquids.
Liquids can flow, even gases can flow because the molecules are weak. They have weak cohesion forces compared to solids. Then let's look at number, we are getting out of time. Let's go to number 5. Number 5, I request Gabriela now, Gabriela. No, Gabby.
Teacher.
Please, can you read?
State one difference between the arrangement of molecules in solids and gases.
Yes. When you look at them, what do you see in their appearance, their arrangement?
The arrangement of molecules in solids are closely packed, while the arrangement of molecules in gases are far apart.
Thank you so much. Thank you so much. So that is our activity 2. I think we may not go for activity 3 and the others because of time, but keep on working hard, revise hard. We are sending you the marking guides. Please make sure you continue reading as we also continue helping you. I thank you so much. You have been so good.
Bye, teacher.
So you are going to go for a break of 30 minutes. And then by exactly 10:30, you have another lesson. I think that is mathematics.
Shekinah, shalom.
Have a nice day.
Bye.
Bye-bye. See you.
Bye. Bye. Bye.